Welcome to our Piping Engineering YouTube channel. We're delighted to provide you free piping education videos designed to enhance your knowledge and skills in the field of piping engineering. Before starting video, make sure to hit the subscribe button and turn on notifications to stay updated with our latest videos. First of all, I would like to express my deep gratitude to our subscribers who became members of our channel. In this video, we'll be showing you step by step how to mark and cut 90-degree elbow to the any degrees elbows with easy method. Let's start our education video. In our previous videos, we learned how to mark and cut a 90-degree elbow to a different degree elbow by drawing a template on a workbench. In this video, we will learn how to mark and cut the pipe elbow using only a tape measure. Let's learn how to mark and cut a 25-degree elbow from a 6-inch 90-degree elbow. Before learning the formula for cutting an elbow by any degree, let's learn arc length formula. We know that the formula for the arc length of the circumference S is equals the circumference of circle C multiplied arc degree A divided by the 360 degrees. Also, we know that the formula for the length of the circumference C is equals 2 multiplied P multiplied the outside radius R. So, arc length formula will be S is equals 2 multiplied P 31.4 multiplied arc radius multiplied arc degree divided 360 degrees. Let's simplify this formula a bit. Multiply and divide the numbers known to us in this formula. Using the calculator, we find that the 2 multiplied 3.14 divided by 360 will be equals 0.01744. So, the length of the arc, S, will be equal, multiplied by 0.01744, the radius of the arc and the degree of the arc. This formula can be used to find the length of arcs of any degree and any radius. Applying this method, we can calculate the lengths of the elbows cut at different degrees from the outside and inside. Let's learn how to mark and cut 25-degree elbow from a 6-inch 90-degree elbow using this formula. We first measure and mark the distance from the outer upper edge of the 90-degree elbow to the length of the 25-degree arc. To calculate this distance, we need to know the radius of the arc according to the arc length formula. If we find the radius of a 6-inch 90-degree elbow, we can easily find the radius of a 25-degree arc. The radius of the 6-inch 90-degree elbow can be found on the elbow dimension chart, or we can calculate it ourselves. Let's first calculate it ourselves and then we can check it with a chart. The formula for calculating the length of 90-degree long radius elbows is as follows. Elbow length in millimeters equals nominal pipe size multiplying 38.1. So, 6-inch 90-degree elbow length will be 6 multiplying 38.1. Using calculator and found 38.1 multiplying 6 will be equals 229 millimeters. Let's check this result with a dimension chart of 90-degree long radius elbows. We can see in the chart, nominal pipe size 6-inch long radius elbow outside diameter is 168.3 millimeters and center to end dimension radius is 229 millimeters. An arc with a radius of 229 millimeters is an imaginary line through the center of a 6-inch 90-degree elbow. As you can see, I have shown it in black color. Also, we know the outside diameter of elbow is 168.3 millimeters. Half of 168 equals 84 millimeters. If we add 84 millimeters to 229, which is the radius of the 6-inch 90-degree elbow, the number obtained will be the radius of the outside blue color arc of the 6-inch elbow. If we subtract 84 millimeters from the 229, which is the radius of the 6-inch 90-degree elbow, the number obtained will be the radius of the inner red color arc of the 6-inch elbow. So, outside radius of the 6-inch 90-degree elbow 229 plus 84 will be equals 313 millimeters. Also, inside radius of the 6-inch 90-degree elbow 229 minus 84 will be equals 145 millimeters. That's good, we are going very well. I hope you are enjoying video. Now, using the arc length formula, let's calculate and mark the length of the 25-degree arc from the inside and outside of the 6-inch elbow. First, let's calculate the length of the blue color arc on the outside of the elbow. So, the length of the outside blue color arc, S, will be equal, multiplied by 0.01744, the radius of the arc, 313 millimeters, and the degree of the arc, 25 degree. Using the calculator, we find that the 0.01744 multiply 313 multiply 25 will be equals 136.5. So, the length of the outside blue color arc, S, will be equal 136.5 millimeters. Now let's calculate the length of the red color arc on the inside of the elbow. So, the length of the inside red color arc, S, will be equal, multiplied by 0.01744, the radius of the arc 145 millimeters and the degree of the arc 25 degree. Using the calculator, we find that the 0.01744 multiply 145 multiply 25 will be equals 63. So, the length of the inside red color arc, S, will be equal 63 millimeters. In fact, this calculation and marking should have been done on a piece of elbow. I have shown the inner and outer arc lengths of elbow in two places so that it is easy to understand. Now we will delete one of the elbows and make the marking in one elbow. Now we have 2 points on the 6-inch elbow. Connect these 2 points along elbow. This line marked on the 6-inch elbow will be the cutting line of the 25-degree elbow, which will be cut from the 90-degree elbow. We saw that if we write the elbow degree and elbow radius to be cut in this formula, we can easily calculate and mark the outer and inner arc length of the desired elbow. By using this method, you can easily calculate arc length and cut any degree elbows. This education video is finishing here. If you find our content valuable, consider supporting us by sharing our videos and recommending our channel to others. Have a topic you're interested in? Let us know. We're always looking for new ideas to cover. We want to express our deep gratitude to all our viewers who have already become members of our channel. Your support is incredibly valuable to us, and it allows us to keep delivering high-quality content and exclusive benefits. Thank you for visiting the Piping Engineering YouTube channel. We're excited to embark on this educational journey with you.